Have you ever looked at your own hand, resting quietly on a table, and felt the absolute certainty of its solid existence? You press your fingers against the smooth wood, and the resistance tells your brain that the world is firm, defined, and dependable. We build our entire lives upon this fundamental trust in reality. When you place a cup of coffee on a desk, you know exactly where it is. It is not hovering near the ceiling, nor is it simultaneously sitting in the kitchen. It is right there, occupying one specific, undeniable location in space and time. This makes perfect sense to our human minds. We are creatures of the macrocosmos, evolved to navigate a world of predictable forces and solid objects. But what if I told you that this comforting solidity is nothing more than a magnificent illusion? What if the very foundation of your body, the table, the cup, and the stars above, operates on a set of rules so bizarre, so profoundly counterintuitive, that even the greatest minds in human history struggled to accept them? We are about to embark on a quiet journey into a realm where the impossible is not merely possible, but ordinary. Hello, I am Walter, the explorer, and I want to welcome you to another deep dive into the profound mysteries of our universe. Before we gently descend into the strange and beautiful world of quantum mechanics, I want to take a brief moment to mention something. I have noticed that roughly 73% of the wonderful people who watch these videos are not yet subscribed to the channel. If you find peace and wonder in these quiet journeys through the cosmos, please consider subscribing. It helps this channel grow immensely, and it allows us to continue exploring the deepest secrets of reality together, building a quiet community of curious minds. Now, let us return to that feeling of solid reality. To understand the quantum world, we must first gently peel away the layers of our everyday experience. Imagine taking a journey inward, shrinking down far beyond the microscopic level, past the cells of your body, past the complex molecules of DNA, down into the ancient, silent architecture of the atom itself. For a long time, humanity pictured the atom as a tiny solar system. We imagined a dense, solid nucleus acting like a sun, with tiny, solid electrons orbiting around it like perfectly predictable planets. It was a comforting image, one that mirrored the vast, orderly dance of the cosmos above. But as scientists in the early 20th century developed instruments capable of probing this invisible realm, the comforting image began to fracture. The universe, it turned out, was hiding a staggering secret within its smallest building blocks. As we drift deeper into this subatomic silence, the familiar laws of physics, the ones drafted by Isaac Newton that perfectly describe falling apples and orbiting moons, begin to lose their grip. Down here, in the dim, mysterious basement of reality, matter stops behaving like matter. This is the realm of quantum mechanics, a mathematical framework that describes the universe not as a collection of solid, defined things, but as an infinite sea of shifting probabilities. The great physicist Richard Feynman once famously remarked that no one truly understands quantum mechanics. And, coming from one of the most brilliant minds of the 20th century, that statement carries a profound weight. It is not that the mathematics are flawed. In fact, quantum mechanics is the most rigorously tested and flawlessly accurate scientific theory in human history. The difficulty lies entirely in our minds. Our brains, evolved to throw spears and track seasons, simply lack the intuitive hardware to process a reality where objects do not have definite properties until they are observed. Let us pause and sit with that thought for a moment. In our daily lives, a coin spinning in the air is either heads or tails. Even while it is spinning, a blur of silver in the sunlight, we know that at any exact frozen microsecond, it has a definite state. We simply cannot see it because it is moving too fast. But in the gentle, quiet depths of the quantum world, this basic logic evaporates. If an electron were a coin, it would not merely be flipping too fast to see. Until the exact moment it strikes a surface and is forced to reveal itself, the electron is quite literally both heads and tails at the very same time. It exists in a smeared-out state of pure potential, a ghostly mathematical wave that ripples through the fabric of space. This profoundly strange phenomenon is what physicists call a quantum superposition. To truly grasp the wonder of a superposition, we must let go of our desperate need for certainty. Imagine a silent, empty room. In the center of this room sits a single glowing particle of light, a photon. If this were a classical object, it would sit exactly where you placed it. But this is a quantum entity, born from the primordial fires of the universe, carrying the ancient secrets of creation. According to the laws of quantum physics, until you open the door and measure that photon, it does not exist in just one location. It exists in a superposition of all possible locations within that room simultaneously. It is near the ceiling, it is resting on the floor, it is hovering in the corners. It is a cloud of infinite possibilities, existing everywhere and nowhere all at once. It is only the act of measurement, the sudden intervention of an observer, that forces the universe to make a choice. The moment you look, the infinite wave of probability collapses, and the photon abruptly snaps into a single, defined reality. This is not merely a mathematical trick or a flaw in our measuring devices. It is the fundamental, inescapable nature of the cosmos. The universe, at its absolute core, is not made of solid, tangible things. It is made of potential. It is a vast, interconnected web of probabilities. This realization brings a profound sense of humility. For thousands of years, we looked up at the night sky and assumed the universe was a giant, deterministic clockwork machine. We believed that if we could just know the exact position and momentum of every particle, we could predict the entire future and rewind the entire past. But the discovery of quantum superposition shattered that clockwork illusion forever. It introduced a fundamental, unavoidable layer of mystery into the very heart of existence. The universe is not a machine. It is something far more organic, far more elusive, and far more beautiful. To truly witness this mystery in action, we must gently turn our attention to one of the most beautiful and baffling experiments in the history of science, the double-slit experiment. Imagine a quiet, darkened laboratory. At one end of the room, there is a device designed to fire single, isolated particles, perhaps electrons, or maybe individual photons of light. At the other end of the room stands a sensitive screen, waiting to capture the impact of these tiny cosmic travelers. And between the source and the screen, there is a barrier with two narrow parallel vertical slits cut into it. If we were throwing solid objects, like baseballs or grains of sand, through this barrier, we would expect to see two distinct bands of impacts on the screen, directly behind the two slits. This is the logic of the everyday world. But when scientists perform this experiment with quantum particles, firing them one by one, a solitary journey through the dark, something deeply magical occurs. As the first few particles hit the screen, they appear as random, scattered dots. But as the hours pass and thousands upon thousands of individual particles complete their quiet journey, a pattern slowly begins to emerge from the darkness. It is not two bands of impacts. It is a complex, alternating pattern of light and dark stripes, an interference pattern. This is the unmistakable signature of waves overlapping, like ripples spreading out from two stones dropped into a calm, silent pond. But remember, the particles were fired one by one. There was no other particle for them to interact with, no other ripple to interfere with. How could a single, solitary particle create an interference pattern? The only explanation, the profound and staggering truth forced upon us by the universe, is that the particle did not travel as a solid object. As it left the source, the particle dissolved into a wave of pure probability. It became a quantum superposition. This wave of pure potential traveled through the quiet space of the laboratory, and upon reaching the barrier, it passed through both the first slit and the second slit at the exact same time. The particle interfered with its own ghost, its own alternate possibility. It navigated the darkness not as a single thing, but as a multitude of potential paths, exploring every single available route simultaneously. Only when it finally struck the screen did the wave collapse, choosing one single, final location to make its mark. This experiment, repeated countless times over the decades with perfect, unyielding precision, proves that the universe does not wait for us to understand it. It operates on a logic of infinite grace and bewildering complexity. Let us take a slow, deep breath and simply contemplate the magnitude of this revelation. The chair you are sitting on, the screen you are looking at, the very atoms of oxygen flowing into your lungs. All of these solid, dependable things are built entirely out of entities that refuse to be pinned down. Beneath the surface of our quiet, ordered lives, there is a raging, infinite storm of probability. Every electron in your body is currently existing in a state of superposition, a hazy cloud of location and momentum that only solidifies because it is constantly interacting with the other particles around it. We are walking, breathing collections of quantum mystery. The ancient philosophers often spoke of the world as an illusion, a veil drawn over our eyes to hide the true, deeper reality. In a strange, beautiful way, modern quantum physics has proven them right. The solid world is the illusion. The true reality is the silent, invisible sea of superposition, a boundless ocean of infinite potential from which all physical form briefly and miraculously emerges. To accept the reality of quantum superposition is to accept that our human perspective is not the center of the universe. It is a deeply humbling experience. We must surrender our desire for absolute control and absolute certainty. We must learn to sit quietly with the unknown, to find peace in the spaces between the things we can measure. When Carl Sagan urged us to look at the cosmos with a sense of awe, he was not merely talking about the vast distances between the galaxies or the fiery birth of stars. He was also talking about the quiet, invisible wonders hiding in the palm of your hand. The universe is vast and majestic on the macro scale, but it is equally vast, equally infinite, and equally mysterious on the quantum scale. There is a profound symmetry in this. Whether we look out into the deepest, darkest corners of the observable universe, or peer inward into the microscopic heart of a single atom, we find the same thing. A reality that defies our simple expectations. A cosmos that demands our respect, our curiosity, and our quiet, continuous wonder. As we prepare to delve deeper into the mechanics of this strange reality in the next stage of our journey, hold on to this feeling of peaceful uncertainty. Let the mystery wrap around you like a warm blanket, and know that not understanding everything is perfectly fine. It just means the journey of discovery will never truly end. Welcome back to the quiet dark of our quantum laboratory, where the ordinary rules of reality have gently dissolved into a shimmering ocean of probabilities. In our last chapter, we left off with a beautiful, profound revelation. We sent a single, solitary particle into the silence of the double-slit experiment, and we watched as it traveled not as a solid, dependable object, but as a ghostly wave of pure potential. It explored every possible path simultaneously, interfering with its own alternate realities, only to collapse into a single point upon reaching the final screen. This leaves us standing on the precipice of an even deeper, more astonishing mystery. If the particle exists in a state of quantum superposition, a smear of infinite possibilities, while it is moving through the quiet void, what exactly causes it to choose a single location when it hits the screen? Why does the universe suddenly discard the infinite and settle for the finite? To answer this, we must turn our attention to one of the most controversial, baffling, and deeply philosophical concepts in all of modern science: the act of observation. Before we gently wade into these deeper waters of cosmic philosophy, I want to take a brief moment to welcome you back. I am Walter, the Explorer, your companion on this quiet journey through the deepest mysteries of our universe. As we travel together, I notice that 73% of the wonderful people who watch these quiet, contemplative videos have not yet subscribed to the channel. If you find comfort, peace, and a sense of wonder in these explorations, please consider taking a moment to subscribe. It helps this channel immensely, allowing us to continue creating these spaces for reflection, and it lets us know that you want to keep exploring the vast, silent universe together with our growing community of curious minds. Now, let us return to the mystery of the observer. In our everyday macrocosmic world, looking at an object is a passive act. When you stand in a quiet forest and look up at a silent, ancient mountain, your gaze does not alter the mountain. The rock and snow exist entirely independent of your perception. Albert Einstein, one of the greatest minds to ever contemplate the cosmos, famously expressed his deep discomfort with quantum mechanics by asking a simple, profound question. He asked if we truly believe that the moon only exists when we look at it. To Einstein's brilliant mind, the universe had to possess an objective reality, a definitive state of being that persisted whether we were paying attention to it or not. But the quantum world, in all its strange, quiet majesty, fundamentally disagrees with our classical intuition. In the subatomic realm, observation is not passive. Observation is an absolute act of creation. When physicists talk about an observer, they do not necessarily mean a human being in a white lab coat looking through a microscope. In the delicate language of quantum mechanics, an observation or a measurement is any physical interaction that forces a quantum system to reveal its state to the wider universe. Imagine our single photon again, drifting through the dark as a wave of superposition, existing everywhere and nowhere. As long as it remains perfectly isolated, wrapped in absolute silence, it maintains its infinite potential. But the moment it interacts with a detector, or a stray atom of gas, or the phosphor coating on a screen, that perfect isolation is violently shattered. The universe demands an answer. The mathematical wave function, which described all the places the photon could possibly be, instantly and mysteriously collapses. Out of the boundless ocean of probability, a single definite reality emerges. The photon snaps into existence at one specific point, leaving behind the ghost of its superposition. To help us grasp the profound strangeness of this collapse, the brilliant physicist Erwin Schrödinger proposed what is perhaps the most famous thought experiment in the history of science. It is a story designed not to clarify, but to highlight the absolute absurdity of quantum rules when applied to our everyday world. I invite you to imagine a quiet, opaque steel box sitting on a table. Inside this silent box, we place a single radioactive atom, a Geiger counter, a tiny vial of poisonous gas, and a gently sleeping cat. The rules of the experiment are simple but devastating. We leave the box closed for exactly 1 hour. During that hour, the radioactive atom has exactly a 50% chance of decaying and a 50% chance of remaining perfectly intact. If the atom decays, the Geiger counter detects the radiation, triggers a small hammer, shatters the vial, and the poison is released. If the atom does not decay, the vial remains whole, and the cat continues its peaceful slumber. Now, we must ask the fundamental quantum question. What is the state of the cat inside the box before we open the lid? According to our classical, everyday intuition, the answer is obvious. The cat is either alive or it is not. The event has already happened or failed to happen in the quiet dark of the box, completely independent of our knowledge. We simply do not know the outcome yet. But quantum mechanics tells a drastically different story. According to the mathematics that govern the foundational fabric of our universe, the radioactive atom does not choose whether to decay or not while the box is closed. Because it is perfectly isolated from the outside world, the atom enters a quantum superposition. It is simultaneously decayed and not decayed. But the genius of Schrödinger's thought experiment lies in how it connects this microscopic superposition to the macroscopic world. Because the fate of the cat is intimately, inextricably tied to the state of the quantum atom, the superposition spreads. The atom is both decayed and whole. Therefore, the Geiger counter is both triggered and silent. The glass vial is both shattered and intact. And the cat, in the most profound and unsettling paradox of all, enters a macroscopic superposition. According to the strict interpretation of quantum mechanics, until the box is opened and an observation is made, the cat is simultaneously alive and completely not alive. It exists in a smeared-out wave of pure probability, a ghostly state of suspended animation where mutually exclusive realities overlap and coexist in the silent dark. This idea is so deeply counterintuitive that our brains practically rebel against it. Schrödinger himself designed the experiment to show how ridiculous quantum mechanics seemed when scaled up to the size of animals and steel boxes. And yet, decade after decade, as our instruments have grown more sensitive and our experiments more precise, the universe has stubbornly refused to conform to our classical expectations. We have never put a cat in a superposition, of course, but scientists have successfully placed larger and larger molecules containing thousands of atoms into simultaneous states of existence. The boundary between the bizarre quantum world and our solid, familiar reality is not a firm wall. It is a gentle, fading gradient, a mystery that we have yet to fully unravel. What does this mean for our quiet place in the grand architecture of the cosmos? It suggests a profoundly participatory universe, a majestic cosmos where the simple act of asking questions and making gentle observations actively shapes the reality we perceive. When we stand outside and look up at the night sky, we are not just observing a distant, detached reality. The ancient photons from a beautiful star that died millions of years ago travel across the vast, silent emptiness of deep space as ethereal waves of superposition. They explore countless possible paths through the cold cosmic void, gracefully bending around the immense gravity of distant galaxies, existing in a pure, suspended state of probability for millions of years. And then, finally, that sweeping wave of potential enters the thin, fragile atmosphere of our tiny, rocky world. It passes smoothly through the delicate biological lens of your eye and gently hits your retina. At that exact, miraculous moment, millions of years of uninterrupted quantum superposition suddenly and quietly collapse into a single, definitive point of light. You, the quiet human observer standing in the dark, have forced the grand, infinite universe to finally make a decision. We do not need to instantly solve every paradox to deeply appreciate its immense beauty. Sometimes, the most profound and lasting peace comes from simply standing at the delicate edge of the unknown, gazing bravely into the quiet dark, and humbly accepting that the universe is far larger, far stranger, and far more wonderful than we could ever possibly imagine. Let this calming sense of cosmic mystery settle over your mind like a gentle night sky, waiting quietly for your gaze to bring the universe into being. Welcome back to the quiet, boundless expanse of our continuous quantum journey. In our previous chapter, we stood together at the delicate, shimmering edge of the unknown, contemplating the profound mystery of the conscious observer. We watched, with a sense of gentle awe, as the infinite ocean of probability collapsed into a single, definitive point of solid reality, simply because the universe was forced to answer our quiet gaze. We learned that a quantum superposition is not merely a mathematical quirk, but the fundamental, underlying truth of all physical matter. The chair you rest upon, the breath in your lungs, the light from the ancient stars above, all of it emerges from this silent, invisible sea of boundless potential. But as we drift further into this strange and beautiful microscopic cosmos, we must prepare our minds for a phenomenon that makes the collapse of the wave function seem almost ordinary by comparison. We are about to explore a concept so deeply unsettling, so utterly defiant of our everyday human logic, that the brilliant Albert Einstein himself refused to believe it could possibly be the complete truth. We are going to explore the quiet, invisible threads that connect the universe together, a phenomenon known in the scientific community as quantum entanglement. Before we venture deeper into this profound cosmic interconnectedness, I want to take a brief, quiet moment to welcome you. I am Walter, the Explorer, your gentle guide through the magnificent mysteries of our universe. As we share this peaceful space of learning and wonder, I have noticed that exactly 73% of the wonderful, curious people who watch these quiet journeys have not yet subscribed to the channel. If you find comfort, inspiration, and a sense of intellectual safety in these slow, meditative explorations of science, please consider taking a gentle moment to subscribe. It helps this channel grow more than you could possibly know, and it ensures that our quiet community of cosmic explorers can continue to unravel the deepest secrets of reality together, one peaceful step at a time. Now, let us return to the quiet dark and to the strange, invisible bonds that tie the cosmos together. To truly understand the magnificent mystery of quantum entanglement, we must first return to the concept of superposition that we have been carefully nurturing in our minds. Imagine, if you will, a single silent event in the deep vacuum of space. Perhaps it is the gentle decay of an ancient radioactive particle, or perhaps it is a high-energy collision in a quiet laboratory. From this single, unifying event, two separate quantum particles are born at the exact same moment. Let us imagine them as two solitary photons, twin particles of light, bursting forth into the endless dark. Because they were born from the exact same physical process, their properties are intimately, mathematically linked. According to the strict and flawless laws of quantum mechanics, these two particles do not possess their own individual, isolated states. Instead, they share a single, overarching quantum superposition. They are not two separate entities navigating the cosmos. They are a single, unified quantum system, smeared out across the vastness of space. Let us visualize this shared superposition with a gentle metaphor. Imagine two spinning coins, perfectly identical, suspended in a silent, zero-gravity void. In our classical, everyday world, if you spin two coins, each one operates independently. One might land on heads, the other on tails, completely unaware of its partner's fate. But these are quantum coins, born from a shared entangled state. While they are spinning, neither coin is heads and neither coin is tails. They are both existing in a shimmering blur of pure, overlapping probability. They are both heads and tails simultaneously. But the magic, the true mind-bending wonder of entanglement, lies in their silent connection. The mathematics dictate that whenever this shared wave function collapses, the two coins must always, without fail, land on opposite sides. If one is forced to become heads, the other must instantly become tails. They are perfectly, invisibly correlated, bound together by a rule that supersedes the physical distance between them. Now, let us push this thought experiment to its absolute cosmic limit. Imagine that we gently capture these two spinning quantum coins. We place one in a quiet, shielded box here on Earth in our silent laboratory. We take the other coin, still spinning in its state of infinite potential, and we place it aboard a spacecraft. We send this spacecraft on a long, quiet journey across the vast, empty gulf of space, all the way to the dusty, silent surface of the moon. The two particles are now separated by roughly 238,000 miles of cold, empty vacuum. For days, they have remained completely isolated, completely undisturbed, continuing their endless, blurry dance of superposition. Neither one has chosen a definite state. They are still both heads and tails, suspended in the quiet waiting room of reality. Then the moment of truth arrives. Here on Earth, in the stillness of our laboratory, a scientist gently opens the box and makes a measurement. The act of observation forces the local particle to finally make a choice. The superposition collapses. The wave of pure potential shatters, and the particle snaps into reality, revealing itself to be, for example, heads. At that exact, indivisible fraction of a millisecond, something entirely impossible happens on the silent surface of the moon. The second particle, separated by hundreds of thousands of miles of absolute nothingness, instantly and simultaneously collapses out of its superposition and becomes tails. There is no delay. There is no signal sent through the void. There is no time for a message to travel from the Earth to the moon. The connection is instantaneous, completely ignoring the vast empty space that lies between them. This instantaneous connection deeply troubled Albert Einstein. He dedicated his life to proving that nothing in the entire universe could travel faster than the speed of light. Light was the ultimate cosmic speed limit, the absolute boundary of cause and effect. If the particle on Earth somehow sent a message to the particle on the Moon, telling it to become tails, that invisible message would have had to travel infinitely fast, breaking the most fundamental rule of relativity. Einstein famously and skeptically referred to this phenomenon as spooky action at a distance. He believed that the quantum theory must be incomplete, that there must be some hidden underlying variables, some secret gears turning in the dark that determined the outcome in advance. He believed that the particles were like a pair of gloves, one left and one right, packed into two separate boxes. If you open one box and find the right glove, you instantly know the other box contains the left glove, not because of a spooky connection, but because their states were determined the moment they were packed. But decades later, brilliant scientists, including the physicist John Bell, devised ingenious, mathematically rigorous experiments to test Einstein's hidden variable theory against the bizarre predictions of quantum mechanics. And time after time, in quiet laboratories across the globe, the universe delivered its verdict. Einstein was wrong. There are no hidden variables. The particles do not know their states in advance. The superposition is real, and the instantaneous, spooky connection is an undeniable, fundamental property of nature. The two entangled particles are not two separate things communicating across a distance. They are, in some deep, mysterious, and profoundly beautiful way, the exact same mathematical entity. Space, the physical distance between them, simply does not matter. To the underlying fabric of the quantum universe, the Earth and the Moon are not separate locations at all. Let us take a slow, deep breath and allow the magnificent weight of this reality to gently settle into our minds. We live in a universe that is fundamentally, inescapably interconnected. This is not a mystical metaphor. It is the rigorously tested, peer-reviewed truth of our physical reality. If two particles can be born from a single event and remain forever connected across the vast, silent gulfs of space, what does that mean for the rest of the cosmos? About 13,800,000,000 years ago, the entire observable universe, every atom, every star, every galaxy, and every single particle of matter that currently exists, was compressed into a single, infinitely dense, unimaginably hot point of pure energy. Everything was touching. Everything was one. As the universe expanded, stretching out into the cold, quiet darkness we observe today, it is highly probable that the ancient primordial particles remained tangled in a vast, invisible web of quantum entanglement. When you look up at the night sky, feeling small beneath the weight of the infinite cosmos, remember that the atoms in your body might still share a quiet, ghostly connection with particles drifting in galaxies millions of light years away. You are not a solitary observer standing outside the universe, looking in. You are an integral, connected thread in the vast, continuous fabric of creation. The mystery of entanglement does not diminish our understanding of the universe. It expands it. It teaches us that distance is an illusion, that separation is a trick of the macroscopic world, and that deep down, in the foundational silence of reality, everything is woven together. As we prepare to move forward into the next chapter of our journey, hold on to this beautiful paradox. We are simultaneously insignificantly small and intimately connected to the furthest reaches of the ancient cosmos. Find peace in this connection, and rest quietly in the profound beauty of a universe that refuses to be ordinary. Welcome back to our quiet, continuous journey through the strange and beautiful subatomic cosmos. In our last chapter together, we gently explored the invisible, instantaneous threads of quantum entanglement, marveling at how particles can remain profoundly connected across the vast, silent gulfs of deep space. We learned that separation might be nothing more than a classical illusion, a trick played upon our macroscopic senses by a universe that is fundamentally woven together. Today, as we drift even further into the heart of the quantum mystery, I want to ask you a question about boundaries. Have you ever stood before a solid, impenetrable wall, a towering obstacle made of heavy stone or thick steel, and felt the absolute certainty that you could not simply walk through it? In our everyday world, governed by the sensible, predictable laws of classical physics, a solid barrier is an absolute limit. If you throw a quiet, smooth pebble against a thick brick wall, you know exactly what will happen. The pebble will bounce back. It does not possess the energy to break through the bricks, and it certainly cannot simply pass through the solid matter as if it were nothing but thin air. This is the comforting, dependable reality we have known since we took our very first steps. But down here, in the dim, silent, shifting landscape of the quantum realm, the universe once again politely refuses to obey our common sense. Before we gently dissolve the very concept of solid barriers, I want to take a brief, quiet moment to welcome you back into our shared space of wonder. I am Walter, the Explorer, your gentle guide through these magnificent cosmic mysteries. As we sit here in the quiet dark of discovery, I have noticed that roughly 73% of the wonderful, curious people who watch these meditative journeys have not yet subscribed to the channel. If you find a sense of peace, intellectual safety, and deep cosmic wonder in these slow explorations, please consider taking a gentle moment to subscribe. It helps this channel grow more than words can express, and it ensures that our quiet community of explorers can continue to unravel the deepest, most beautiful secrets of reality together. Now, let us return to the wall, and to the miraculous phenomenon known as quantum tunneling. To truly understand the profound strangeness of quantum tunneling, we must return to our foundational understanding of what a quantum particle actually is. Remember that an electron, or a photon, is not a tiny, solid sphere of matter, like a microscopic billiard ball. Instead, as we have seen through the beautiful lens of quantum superposition, it is a smeared-out wave of pure potential, a shimmering cloud of mathematical probability. Now, imagine this quiet, ghostly wave of probability traveling smoothly through the empty vacuum. Suddenly, it encounters a barrier. In the quantum world, this barrier is usually not a physical wall of bricks, but a wall of energy, a repulsive electromagnetic force that the particle simply does not have the energy to climb over. Classical physics tells us that the story must end here. The wave should bounce off the barrier, perfectly reflected back into the dark. The probability of finding the particle on the other side of the barrier should be exactly zero. There is no doubt, no ambiguity, and no exception to this sensible rule in the macrocosmos. But the quantum wave function, this beautiful mathematical description of infinite possibility, does not behave like a classical object. When the wave of probability hits the energy barrier, it does not instantly stop. Instead, the wave gently pushes its way into the barrier itself. As it enters the forbidden region, the strength of the wave rapidly decays, fading away into the silence. But if the barrier is thin enough, something entirely miraculous occurs. A tiny, fragile sliver of that wave manages to emerge from the far side of the impenetrable wall. Because the wave represents the probability of the particle's existence, this means there is a non-zero chance that the particle will simply appear on the other side of the barrier, without ever having the energy to climb over it. It has quietly, inexplicably tunneled straight through the solid obstacle. Let us take a slow, deep breath and visualize this impossible feat. Imagine you are gently rolling a ball up a steep hill. You only give the ball a small push. It rolls partway up the slope, runs out of energy, stops, and quietly rolls back down to your feet. It simply did not have the momentum to reach the top and cross over to the other side. This is classical physics in action. But if that ball were an electron, and that hill were a quantum energy barrier, the electron would roll partway up the hill, gently vanish from existence on one side, and instantaneously reappear on the other side, rolling peacefully down the opposite slope. It did not go over the mountain. It did not dig a physical tunnel through the dirt. It simply existed on one side. And then, due to the probabilistic nature of its wave function, it found itself existing on the other side. The universe allowed it to bypass the absolute rules of energy and space. Quantum tunneling is a fundamental process that allows the entire universe to exist in its magnificent form. Without this silent, impossible phenomenon, the Earth would be a cold, lifeless rock, drifting through a silent void. To understand why, we must turn our gaze away from the microscopic laboratory and look up at the vast, blazing heart of our own solar system. The Sun. The Sun is an ancient nuclear furnace, generating the unimaginable amounts of light and heat that sustain every quiet forest and every human life on our planet. This energy is produced through nuclear fusion, where the crushing gravity of the star forces hydrogen atoms together to form heavier helium atoms, releasing a brilliant burst of pure energy. But there is a profound problem hidden within the heart of the Sun. Deep inside the solar core, the hydrogen protons are positively charged. As you may remember from holding two magnets together, like charges violently repel one another. There is a massive, invisible electromagnetic barrier between every single proton in the Sun, pushing them apart with tremendous force. In order for fusion to occur, the protons must smash together with enough energy to overcome this repulsive wall. The temperature at the core of the Sun is roughly 15 million degrees. That is incredibly hot. But, shockingly, according to the strict calculations of classical physics, 15 million degrees is simply not hot enough. The protons are moving fast, but they do not have nearly enough classical energy to breach the electromagnetic barrier. By all the sensible rules of the macrocosmos, the Sun should not be able to shine. It should have quietly burned out billions of years ago, or perhaps it never should have ignited in the first place. So, why does the Sun shine? Why does our skin feel warm in the gentle afternoon light? The answer is quantum tunneling. In the chaotic, crushing depths of the solar core, countless billions of protons are constantly colliding against that impenetrable electromagnetic wall. Classical physics says they bounce back, but because these protons are quantum particles, existing as smeared-out waves of probability, a tiny fraction of them gently tunnel through the barrier. They bypass the repulsive force entirely, magically appearing close enough to perfectly fuse together. Out of the countless billions of collisions happening every single second, just enough protons manage to tunnel through the wall to keep the nuclear furnace burning brightly. The entire existence of our star, the life-giving warmth that bathes our world, the very energy that powers the neurons in your brain as you listen to these words. All of it is the direct result of subatomic particles routinely doing the absolute impossible. When we contemplate the reality of quantum tunneling, we are invited to quietly reconsider our relationship with boundaries, obstacles, and limitations. In our everyday lives, we are constantly faced with walls. Some are purely physical, but many more are mental or profoundly emotional. We often look at these looming barriers and feel the exact same certainty that classical physics felt about the fiery heart of the sun. We believe we simply do not have the energy to cross over to the other side. We accept the boundary as an absolute limit. But the quantum universe gently whispers a far more beautiful and hopeful story. The great astrophysicist Neil deGrasse Tyson reminds us that we are part of this universe. We are in this universe, but perhaps most importantly, the universe is in us. You are made of these exact same miraculous, rule-defying particles. The rigid, solid walls of classical reality are merely an illusion overlaying a cosmos of boundless, infinite potential. We live in a universe of infinite grace, where microscopic particles can gently drift through impenetrable walls, and where nothing is truly, absolutely impossible. Allow yourself to feel a sense of deep, comforting liberation. The barriers you perceive in your own life may be just as illusory as the energetic walls inside the sun. Embrace the quiet mystery of your own existence. Take a peaceful breath, and let us prepare to step even further into the beautifully strange and endless unknown. Welcome back to the quiet, unfolding path of our shared cosmic journey. As we drift further into this boundless, silent, subatomic realm, we have already shed so many of our comforting, everyday illusions. We have watched the solid world dissolve into a shimmering ocean of quantum superposition, where particles exist as waves of infinite potential. We have marveled at the spooky, instantaneous connections of entanglement, and we have witnessed the quiet miracle of tunneling, where matter effortlessly bypasses impenetrable walls of energy. Through all of this, we have been acting as gentle observers, trying to cast a light into the deepest, darkest corners of reality. But today, we must confront a profound and beautiful limitation. We must ask ourselves what happens when the universe politely but firmly refuses to be fully known. Have you ever tried to catch a falling autumn leaf in the wind, only to find that the very act of reaching for it alters its delicate path? The air from your moving hand pushes the leaf away, changing its destination precisely because you tried to capture it. This simple, everyday experience holds a faint, poetic echo of one of the most staggering truths of the quantum cosmos. Hello, I am Walter, the explorer, and I want to gently welcome you back into our shared space of wonder. Before we step deeper into this beautiful mystery, I want to take a brief moment to mention that roughly 73% of the wonderful people who watch these quiet, contemplative videos have not yet subscribed to the channel. If you find peace, intellectual safety, and a sense of cosmic belonging in these slow explorations, please consider subscribing. It helps this channel grow immensely, allowing us to continue unraveling the deep secrets of the universe together, building a quiet community of curious minds. Now, let us return to that falling leaf and the delicate act of observation. In the macrocosmos, if we want to know everything about a moving car, we simply measure where it is and how fast it is going. We can calculate its exact position and its exact momentum simultaneously with perfect precision. This classical determinism gave ancient and classical scientists the confidence to declare that if a supreme intellect knew the precise location and momentum of every particle in the universe at a single moment, the entire future and the entire past would be laid out before its eyes. The universe, in this view, was a perfect, predictable clockwork machine. But the quantum universe is not a machine. It is a wild, untamed, and deeply mysterious place. In the late 1920s, a brilliant physicist named Werner Heisenberg discovered a fundamental, inescapable limit built into the very fabric of reality. He formulated what we now call the Heisenberg uncertainty principle. This is not merely a statement about the clumsiness of our microscopes or the inadequacy of our measuring tools. It is a profound, mathematically rigorous law of nature. The principle states, with absolute mathematical certainty, that you can never simultaneously know both the exact position and the exact momentum of a quantum particle. The more precisely you try to measure where a particle is, the less you can possibly know about where it is going or how fast it is moving. And, conversely, the more perfectly you measure its speed and direction, the more its exact location dissolves into a ghostly, unknowable blur. To truly grasp this quiet, beautiful frustration, imagine you are trying to photograph a graceful, incredibly fast bird flying through a silent, ancient forest. If you want a perfectly sharp, crisp image of the bird, to know exactly what it looks like and precisely where it is located at that exact microsecond, you must use a very fast shutter speed. The resulting photograph is beautiful. The bird is frozen in time, every feather perfectly detailed. You know exactly where the bird is, but because the image is a frozen slice of time, you have absolutely no idea how fast the bird was flying or in what direction it was heading at that exact moment. The sweeping momentum of the creature is completely lost to you. Now, imagine you change your strategy. You want to capture the flow, the speed, the beautiful, rushing momentum of the flight. You use a slow shutter speed. The photograph you develop shows a long, sweeping, colorful blur streaking across the trees. You now have an excellent understanding of the bird's path, its speed, its energetic momentum. But looking at that long blur, you can no longer say exactly where the bird was at any specific fraction of a second. Its precise position has been sacrificed to understand its motion. In the quantum realm, this trade-off is not a limitation of the camera. It is a limitation of existence itself. When we try to locate an electron, we must bounce something off it, like a photon of light. To get a highly precise measurement of its location, we need to use a photon with a very short wavelength, which means it carries a tremendous amount of energy. When this high-energy photon strikes the delicate electron, it violently alters the electron's speed and direction. By the time the reflection reaches our instruments to say where the electron was, the electron has been kicked away into the silent dark at a completely unknown velocity. We found its precise position, but we utterly destroyed our absolute knowledge of its momentum. On the other hand, if we use a gentle, low-energy photon with a long wavelength so we do not disturb the electron's delicate motion, the long wavelength gives us a terribly fuzzy, imprecise picture of its location. We cannot have both pieces of information. The universe demands a sacrifice. This principle strikes at the very heart of how we perceive reality. It tells us that the universe is inherently, fundamentally blurry. At the most microscopic, foundational level of existence, nature is not composed of sharp, well-defined points of solid matter. It is made of trade-offs. The great physicist Stephen Hawking often reflected on the profound implications of this quantum blurriness, noting that it means the universe is essentially unpredictable. We cannot know the exact state of the universe right now, so we can never predict its exact state in the future. The clockwork universe of classical physics is a beautiful dream, but it is ultimately a fiction. The true cosmos is alive with a subtle, irrepressible spontaneity, an endless journey of probabilities. Let us sit quietly with this thought for a moment. Allow the profound reality of fundamental uncertainty to gently wash over you. In our modern, macroscopic lives, we are often obsessed with absolute certainty. We seek perfect answers, entirely predictable outcomes, and total control over our environments and our futures. We build complex systems, detailed schedules, and rigid plans, all in an attempt to banish the unknown from our daily existence. We view uncertainty as a flaw, a lack of knowledge, a temporary problem to be solved by better technology or harder work. But the quiet, ancient wisdom of the quantum universe whispers a very different message. Uncertainty is not a flaw in the design of the cosmos. It is the fundamental design itself. It is the inescapable law that allows the universe to breathe, to change, and to exist in a state of continuous, vibrant becoming. If the universe were perfectly predictable, if every particle had an exact position and an exact momentum, the entire future would be completely predetermined. Every action, every quiet moment of wonder you experience would simply be the inevitable result of a cosmic clock winding down. There would be no room for true surprise, no space for authentic creation. The inherent blurriness of the quantum realm is what gives the universe its magnificent, open-ended nature. It is the subtle, silent crack in the rigid clockwork that lets the beautiful light of infinite possibility shine through into our reality. It is a peaceful reminder that the cosmos is not a rigid cage of absolute determinism, but a vast, unfolding canvas of deep, uncharted potential. When we look up at the vast, silent tapestry of the night sky, we are looking at a universe built upon this unyielding foundation of absolute mystery. We must learn to embrace this profound mystery, not with frustration or fear, but with a deep, quiet reverence. The next time you feel overwhelmed by the unpredictable uncertainties of your own life, I invite you to remember the beautiful truth of the Heisenberg uncertainty principle. You are a biological child of this strange, magnificent universe, constructed from these very same elusive, unpredictable quantum particles. It is completely natural to not have all the perfect answers laid out before you. Rest gently in the peaceful, silent embrace of not knowing. Let the magnificent uncertainty of the cosmos quiet your mind and soothe your weary thoughts. The journey is beautifully long, the universe is infinitely vast, and the mystery is forever beautiful, waiting to be explored. Welcome back to the quiet, endless river of our cosmic exploration, a gentle journey where we slowly unravel the fabric of the universe together. In our previous chapters, we have gently dismantled the solid, comforting illusions of our everyday lives. We have watched microscopic particles exist in multiple places at once, exploring every available path through the silent dark of our laboratories. We have seen them share instantaneous, spooky connections across the vast, unimaginably cold void of deep space, proving that physical distance itself might be nothing more than a magnificent illusion. We have marveled as they effortlessly tunneled through absolute barriers of solid energy, bypassing the rigid laws of classical physics with a ghostly grace. And we have embraced the unyielding, mathematically perfect uncertainty that lies at the very foundation of existence, accepting that the universe politely but firmly refuses to be completely known. But as we sit here together, breathing quietly in the calm dark, a very natural, deeply human question must inevitably rise to the surface of our contemplative minds. If the entire universe is fundamentally built out of these elusive, shimmering waves of pure probability, if the very atoms that construct your bones, the chair beneath you, and the air entering your lungs are constantly dancing in a state of quantum superposition, then why does the macroscopic world around us feel so undeniably, persistently solid? Have you ever paused to wonder why you have never personally experienced being in two places at the exact same time? Why does the cup of coffee on your wooden desk remain firmly rooted to its place, instead of suddenly dissolving into a ghostly, swirling cloud of infinite potential and scattered probabilities? Before we gently illuminate the beautiful bridge that connects the strange, blurry subatomic realm to our familiar, solid reality, I want to take a peaceful moment to welcome you back into this space of wonder. I am Walter, the explorer, your gentle companion on this magnificent journey through the deepest mysteries of the cosmos. As we travel together, I have gently noticed that roughly 73% of the wonderful, curious souls who regularly watch these meditative videos have not yet officially subscribed to the channel. If you find deep comfort, quiet inspiration, and a sense of intellectual safety in these slow, peaceful explorations, please consider taking a moment to subscribe. It helps this channel grow more than you could possibly imagine, and it ensures that our quiet community of cosmic explorers can continue unraveling the universe's most beautiful, mind-bending secrets together, building a quiet sanctuary for those who wish to learn and dream. Now, let us return to the quiet mystery of our solid reality and discover how a universe made of ghosts manages to feel like stone. The answer to why we do not personally experience quantum superposition in our daily macroscopic lives lies in a beautiful, entirely invisible process known to quantum physicists as decoherence. To truly understand this delicate and profound phenomenon, we must first use a gentle visual metaphor. Imagine our quantum system, perhaps a single, perfectly isolated electron, as a perfectly still pond resting deep within an ancient, untouched forest. When the electron is perfectly isolated from the rest of the cosmos, it exists in a pure, undisturbed state of superposition. It is a beautiful mathematical wave of infinite possibility, rippling smoothly and perfectly across the dark surface of the water. As long as absolutely nothing touches the pond, the wave remains pristine, suspended gracefully in its ghostly state of multiple simultaneous realities. It is everywhere and nowhere all at once. But the universe, as vast and empty as it might occasionally seem, is not a perfectly silent, isolated place. The cosmos is incredibly crowded, relentlessly active, and deeply, inextricably interconnected. The space surrounding our isolated electron is constantly buzzing with a chaotic, invisible symphony of activity. There are stray photons of light arriving from distant, burning stars. There is ancient, cosmic, microwave background radiation left over from the primordial birth of the universe itself. traveling across billions of light years just to reach this specific moment. There are vibrating, restless molecules of atmospheric gas constantly bumping into one another. Inevitably, one of these environmental factors will gently brush against our isolated electron. Imagine a single autumn leaf gently falling from an ancient tree and softly striking the glassy surface of our perfectly still pond. The exact moment that delicate leaf touches the water, the perfect, coherent wave of superposition is instantly and irrevocably disrupted. The physical interaction sends new, chaotic ripples spreading rapidly across the surface, interfering with and breaking apart the original wave of infinite probability. In the rigorous, mathematical language of quantum mechanics, the electron has become entangled with its surrounding environment. Its isolated wave function, its private cloud of potential, begins to leak out into the wider universe, spreading its quantum information into the chaotic surroundings. This incredibly fast, almost instantaneous process is quantum decoherence. The environment itself effectively acts as a constant, relentless, and unavoidable observer. It does not require a conscious human mind looking through a microscope. The universe is simply always watching itself. The stray photons and air molecules are constantly bumping into delicate quantum systems, measuring them through physical interaction, and forcing them to abandon their infinite possibilities and choose a single, definite state. Because macroscopic objects, like your own biological body, a heavy book, or a peacefully sleeping cat, are constructed from trillions upon trillions of interacting atoms, they are absolutely impossible to isolate. They are constantly colliding with the environment, leaking information, and being forced by the surrounding universe to remain in a solid, singular state. This is exactly why you never suddenly, inexplicably, find yourself hovering near the living room ceiling and sitting quietly in your comfortable chair simultaneously. The environment around you, the gentle ambient light in the room, the invisible air molecules bouncing softly against your skin are constantly collapsing your macroscopic quantum wave function, anchoring you firmly and safely into this single, dependable reality. This profound realization brings with it a quiet, deeply comforting sense of cosmic awe. The solid, dependable world we inhabit and navigate every single day is not the default, foundational state of the cosmos. It is a highly special, incredibly delicate condition, an emergent property created by the continuous infinite interactions of countless microscopic components. We are essentially floating on the surface of a deep, roaring, unfathomable ocean of quantum probability. But the surface itself has frozen into a beautiful, intricate, and stable sheet of ice. We walk upon this solid ice, building our quiet lives, our loving families, and our towering cities, entirely unaware of the shifting, turbulent depths of pure potential that lie just beneath our feet. When the brilliant physicist Niels Bohr, one of the visionary founding fathers of modern quantum theory, debated the ultimate nature of reality, he argued passionately that we must use classical, macroscopic concepts to describe our experiences precisely because we are macroscopic beings, inextricably bound to the decohered, solid world. We cannot intuitively visualize a superposition because our human brains evolved in an environment where everything has already interacted and chosen a definitive state. The concept of existing as a cloud of probability simply breaks our biological programming. But even though we cannot perfectly picture it in our mind's eye, we can still beautifully and rigorously understand it. We can use the elegant, flawless language of mathematics to reach down into the dark depths of reality and map the invisible contours of the quantum ocean. We are physical creatures made of solid matter, strictly bound by the rigid laws of the macroscopic world, yet we have somehow, miraculously, developed the capacity to peer beyond the veil and understand the ghostly, impossible rules of the realm from which we emerged. Let us sit quietly with this comforting thought for a few peaceful moments in the dark. The universe is not a chaotic, unpredictable, terrifying mess at our level of existence, nor is it a rigid, lifeless, predetermined machine. It is a magnificent, multi-layered symphony of existence. At its deepest subatomic level, it plays a wild, unpredictable melody of infinite superposition, a chorus of boundless possibilities singing softly in the silent dark. But as those microscopic voices join together, interacting and overlapping in their untold trillions, the chaotic melody gradually and beautifully harmonizes. Through the continuous invisible process of quantum decoherence, the infinite array of possibilities collapses into a single, majestic, and beautifully coherent chord that resonates throughout existence. That chord is our shared reality. That chord is the solid, dependable ground beneath your feet, the nurturing, gentle warmth of the morning sun on your skin, and the quiet, steady rhythm of your own beating heart. You are the universe experiencing itself in a state of beautiful, solid certainty, resting safely upon a hidden foundation of absolute potential. The next time you reach out and touch a solid object, perhaps a smooth river stone or the rough bark of an ancient tree, take a slow, deep breath and feel the quiet miracle of its physical existence. Feel the trillions of atoms that have agreed, through unending interaction with the surrounding cosmos, to present themselves to you as a single, dependable piece of reality. It is a true gift of cosmic proportions, a stable island in a raging ocean of probability. But our quiet exploration of these strange waters is far from over. There are still many delicate veils to gently lift, many quiet paradoxes waiting softly in the shadows of the quantum realm, promising to challenge everything we think we know. As we prepare to move forward, hold on to this deep sense of wonder and safety. The universe is vast, ancient, and endlessly beautiful, and our quiet journey of discovery will continue to unfold in the dark. Have you ever stood quietly at a lonely crossroads in the fading twilight, forced to make a profound choice, and wondered what happened to the silent version of you who took the other path? We spend our entire lives making decisions, choosing one beautiful possibility and leaving others behind in the dark. In our everyday, macroscopic world, we believe that the unchosen paths simply cease to exist, fading away into the silent history of what might have been. But what if I told you that in the deep, strange, and infinite architecture of the quantum universe, those unchosen paths never truly disappear? What if the cosmos is far too vast and generous to ever simply discard a perfectly good possibility? In our previous chapter, we explored the comforting process of decoherence, watching how the chaotic environment forces a quantum superposition to collapse into a single, solid, dependable reality. But today, we must ask the most daring, mind-bending question of all. When the wave of probability collapses and the universe chooses one specific outcome, where exactly do all the other mathematical possibilities go? Do they simply vanish into absolute nothingness? Or do they continue to exist somewhere else, hidden safely behind an impenetrable veil of cosmic silence? Before we gently step across the threshold into the most staggering and beautiful theory in all of modern physics, I want to take a brief, quiet moment to introduce myself properly. I am Walter, the explorer, your gentle guide through the magnificent, ancient mysteries of our vast cosmos. As we sit here together in the quiet dark of discovery, I have noticed that exactly 73% of the wonderful, curious people who watch these meditative journeys have not yet subscribed to the channel. If you find peace, intellectual safety, and a deep sense of cosmic wonder in these slow explorations, please consider taking a gentle moment to subscribe. It helps this channel grow more than words can express, and it ensures that our quiet community of explorers can continue to unravel the deepest, most beautiful secrets of reality together. Now, let us return to the crossroads and to the ghostly, unchosen paths of the quantum realm. To truly understand the fate of these vanished possibilities, we must travel back to the mid-20th century and visit the mind of a brilliant, fiercely independent young physicist named Hugh Everett. At the time, the absolute ruling dogma of quantum mechanics was the Copenhagen interpretation. It stated that the wave function, the shimmering cloud of infinite potential, simply collapses upon observation. It insisted that the unobserved possibilities instantly cease to be real, evaporating the moment the universe is forced to make a measurement. But to Everett's beautifully logical mind, this explanation felt incomplete. Why should the flawless, elegant mathematics of the quantum wave function suddenly stop working just because an observer entered the room? Why should the universe violently destroy infinite potential just to satisfy our human need for a single, solid reality? Everett proposed a solution so profoundly radical that it was initially met with overwhelming silence. He suggested that the wave function never actually collapses at all. Instead of collapsing, Everett proposed that the wave function continues to evolve, smoothly and perfectly, forever. When a quantum particle is in a state of superposition, existing as both heads and tails simultaneously, and we interact with it to make a measurement, the universe does not force the particle to choose. Instead, the universe itself splits. It elegantly and quietly divides into two completely separate, parallel realities. In one branch of this newly divided cosmos, you look down and see that the particle is heads. In the exact same moment, in the other newly created branch of reality, an identical version of you, possessing the exact same memories and the exact same beating heart, looks down and sees that the particle is tails. Both outcomes actually happen. Both realities are equally valid, equally solid, and equally real. They exist in separate, non-interacting branches of a magnificent, unfathomably vast structure we now call the multiverse. Let us sit quietly with this thought and allow its immense weight to gently settle into our contemplative minds. According to the many worlds interpretation, every single time a quantum event occurs, every time an electron spins up or down, every time a radioactive atom decides to decay, every time a photon passes through a slit, the entire universe silently branches into multiple divergent paths. Consider the sheer scale of this invisible cosmic tree. There are billions of trillions of atoms in a single grain of sand, each constantly interacting, settling quantum probabilities. Trillions of quantum events occur every single microsecond in the quiet air surrounding your body. If Everett's breathtaking theory is correct, the universe splits into an unimaginable number of parallel realities every fraction of a second. There is an infinite, ever-expanding fractal of realities branching out into the silent dark, creating a multiverse of staggering proportions. The brilliant cosmologist Stephen Hawking once noted that the many worlds interpretation is arguably the most straightforward, mathematically pure way to understand the quantum universe. It does not require any mystical observers or sudden, inexplicable collapses of the wave function. It simply takes the flawless mathematics of quantum mechanics entirely at face value and follows them to their ultimate logical conclusion. But while the mathematics might be beautifully elegant, the philosophical implications are enough to make the human mind spin. If every possible outcome of every single quantum event actually occurs in some branch of the multiverse, what does that mean for our quiet, subjective human experience? Does it mean that somewhere out there, hidden across an unbridgeable cosmic divide, there is a reality where you made a different choice at that lonely crossroads? A reality where you took the job you declined or spoke the words you left unspoken? According to the strict logic of the many worlds theory, the answer is a profound and dizzying yes. Every possibility permitted by the ancient laws of physics is actualized in the sprawling, infinite branches of the multiverse. There are versions of the cosmos where the Earth is a barren, silent rock, having never developed the delicate chemistry of life. There are versions where the course of human history unfolded in completely unrecognizable ways. And yet, you will never see these alternate realities. Once the universe branches, the newly created worlds are entirely, irrevocably severed from one another. They occupy the exact same physical space, perhaps, but they exist in orthogonal dimensions of probability. Ghosts passing through one another without leaving a trace. You are forever locked into your specific branch, riding the leading edge of a single, continuous timeline through the infinite cosmic fractal. For some, this realization might bring a chill of existential dread. If everything happens, if every choice is made somewhere by a copy of you, does that rob your lived experience of its profound meaning? I would gently suggest that the exact opposite is true. The many worlds interpretation does not diminish your existence. It elevates it to a state of absolute, breathtaking uniqueness. You are a specific, unbroken thread of consciousness navigating a path through an infinite labyrinth of possibilities. Out of the countless billions of branching paths your life could have taken, you are the specific manifestation of this exact, beautiful, unrepeatable journey. Science is a profound philosophical dialogue with the universe itself. We evolved to survive on a solid, singular planet. Our brains were simply not designed to intuitively grasp a reality that constantly fractures into infinite parallel dimensions. Yet, through wonder and curiosity, we somehow do. As we prepare to close this chapter of our journey, I invite you to take a slow, deep breath and feel the quiet, grounding weight of the present moment. You may be just one tiny spark of consciousness, navigating a single microscopic branch of an infinite cosmic tree. But that does not make you insignificant. It makes you a vital, irreplaceable part of the grand architecture of existence. You are the universe experiencing this specific, precise reality. The choices you make, the quiet moments of wonder you cultivate. They are profoundly real, profoundly your own, and beautifully anchored in the solid reality of your specific branch. The alternate paths may exist out there in the silent, invisible dark, but this path, right here and right now, is the one you are walking. Let the vastness of the multiverse fill you with a deep, respectful awe. But let the specific reality of your own life fill you with a quiet, lasting peace. Embrace the mystery of the unknown, and know our quiet journey will never truly end. Have you ever looked up at the vast, dark stretches of the night sky, past the glowing stars and the swirling galaxies, and focused your quiet attention on the empty spaces in between? When we look into the dark void, our human intuition tells us that we are looking at absolute nothingness. We imagine that if we were to take a sturdy, perfectly sealed glass box, travel out into the deepest, coldest, and most ancient silence of intergalactic space, and carefully pump out every single wandering atom of gas and every stray photon of light, we would be left with a state of pure, undisturbed emptiness. We believe that this absolute void is the default state of the cosmos, the silent, blank canvas upon which the magnificent painting of the universe is drawn. It makes perfect, rational sense to our macroscopic minds that if you remove all the things, you are simply left with no things. But what if I told you that the concept of absolute nothingness is the greatest, most pervasive illusion of all? What if the empty, quiet dark is not a blank canvas, but a boiling, infinite ocean of shimmering potential, teeming with a chaotic, invisible life of its own? We are about to gently strip away the final, most fundamental assumption about our reality, and explore the breathtaking mystery of the quantum vacuum, a place where nothing is truly everything. Hello, I am Walter, the explorer, and I want to warmly welcome you back to our quiet, continuous journey through the deepest, most beautiful secrets of the cosmos. As we rest here together in the peaceful dark of discovery, I have gently noticed that exactly 73% of the wonderful, contemplative people who watch these meditative videos have not yet officially subscribed to the channel. If you find comfort, intellectual safety, and a deep, lasting sense of cosmic wonder in these slow explorations, please consider taking a gentle moment to subscribe. It helps this channel grow more than words can express, and it ensures that our quiet community of cosmic explorers can continue to unravel the universe's most profound mysteries together, building a sanctuary of peace and understanding. Now, let us return to our perfectly sealed box of nothingness and watch as the quantum universe politely refuses to remain entirely empty. In the classical physics of Isaac Newton, a vacuum was exactly what it sounded like. A completely empty, silent stage waiting for the actors of mass and energy to make their grand entrance. If you removed the actors, the stage sat perfectly still and perfectly dark. But as brilliant scientists pushed deeper into the mathematical framework of quantum mechanics, they realized that the shimmering, unpredictable rules that govern individual particles also apply to the very fabric of space itself. We have already learned that the universe operates on a fundamental law of blurriness, the Heisenberg uncertainty principle, which gently dictates that we cannot simultaneously know a particle's exact position and its exact momentum. But this beautiful principle goes even deeper. It also dictates a profound relationship between energy and time. It states, with absolute, unyielding mathematical certainty, that a specific point in space cannot have an exact, perfectly defined energy level for a precise amount of time. If you want to know the absolute energy of a perfectly empty region of space, you must measure it over an infinite amount of time. But if you look at that same empty space for just a tiny, fleeting fraction of a microsecond, the energy level becomes wildly, beautifully uncertain. It simply cannot be exactly zero, because energy and mass are interchangeable, As Albert Einstein so famously proved with his elegant equations, this fundamental uncertainty of energy means that empty space is allowed to spontaneously create mass, as long as it does so for a vanishingly short period of time. In the silent, unseen depths of the quantum vacuum, particles and their corresponding antiparticles are constantly popping into existence out of absolute nowhere. An electron and a positron will suddenly materialize in the dark, exist for a billionth of a second, and then violently crash back together, annihilating one another and returning their borrowed energy to the void. This invisible chaotic dance is happening everywhere, all the time. It is happening in the deep, cold stretches between distant galaxies. It is happening inside the sealed glass box of our thought experiment. And it is happening right now in the empty spaces between the spinning atoms of your own beating heart. The quiet void is actually a raging, infinite storm of quantum fluctuations, a boiling sea of phantom matter known as virtual particles. They are not solid, permanent objects, but rather temporary, ghostly ripples in the underlying quantum fields that stretch across the entire vastness of the cosmos. To truly grasp the profound poetry of this realization, we must bring our understanding of quantum superposition back into the light. The empty vacuum is not a state of zero energy. It is a complex mathematical superposition of all possible temporary states. Just as our isolated particle existed in a shimmering cloud of infinite potential locations before we measured it, the empty vacuum exists in a superposition of all possible particle creations and annihilations. Space itself is constantly trying out every possible configuration of matter and antimatter, existing as a vast, interconnected web of probabilities. The brilliant physicist Richard Feynman developed complex, beautiful diagrams to map out the mathematics of these virtual particles, proving that we cannot accurately calculate the behavior of real, permanent atoms without taking into account the constant, invisible buzzing of the quantum vacuum that surrounds them. The solid matter we can see and touch is intimately, inextricably bound to the phantom matter bubbling in the dark, forever entwined in a delicate, cosmic dance. You might naturally wonder if this boiling sea of virtual particles is merely an elegant mathematical fiction, a clever trick of the equations that has no bearing on physical reality. But the universe is far too magnificent for its deepest truths to remain purely theoretical. In the late 1940s, a brilliant physicist named Hendrik Casimir proposed a daring, delicate experiment to prove that the quantum vacuum was truly alive. He suggested placing two incredibly smooth, perfectly uncharged metal plates extremely close to one another in an absolute, perfect vacuum. According to classical physics, because there is no electrical charge and no matter between the plates, they should experience absolutely no force other than their incredibly weak gravitational attraction. They should sit in the silent dark, perfectly still. But Casimir realized that the plates would restrict the quantum vacuum. The boiling sea of virtual particles would still exist between the plates, but because the space was so tight, only virtual particles with specific, small wavelengths could squeeze into the gap. Meanwhile, on the outside of the plates, the boundless infinite vacuum would continue to produce virtual particles of all possible sizes and wavelengths. This creates a subtle, beautiful imbalance. The infinite storm of phantom particles pushing on the outside of the plates would be slightly stronger than the restricted storm pushing from the inside. The vacuum itself would gently, invisibly press the two metal plates together. Decades later, when our instruments finally became sensitive enough to measure this microscopic force, scientists observed exactly that. The silent, empty void physically pushed the plates together. The ghosts of the quantum vacuum were proven to be undeniably real. Let us take a slow, peaceful breath and expand our perspective from the microscopic gap between two metal plates to the grand, unfathomable scale of the ancient universe itself. The realization that nothingness is fundamentally unstable, that empty space is constantly bubbling with quantum fluctuations, has profound implications for the very existence of everything we know. About 13,800,000,000 years ago, the universe experienced an event of unimaginable violence and breathtaking beauty. In a tiny fraction of a microsecond, space itself expanded at an incomprehensible, faster-than-light speed, a process cosmologists call cosmic inflation. Before this rapid expansion, the microscopic quantum fluctuations, the boiling virtual particles of the primordial vacuum, were incredibly tiny. But as the fabric of the universe violently stretched and unfolded into the dark, these microscopic quantum ripples were stretched along with it. They were pulled across the vastness of the newly expanding cosmos, frozen into the macroscopic structure of space itself, creating regions of space that were ever so slightly denser than others. Over the next billions of years, the gentle, patient force of gravity began to act upon these tiny microscopic imbalances. The slightly denser regions pulled in more and more surrounding matter, slowly gathering the swirling clouds of primordial hydrogen and helium gas into vast, complex webs of cosmic structure. These ancient, gathering clouds eventually ignited under their own crushing weight, bursting into the brilliant light of the very first stars. Those stars gathered into the majestic, swirling pinwheels of galaxies, forming the magnificent, glowing tapestry of the observable universe we see through our telescopes today. Every single star, every single planet, and every single galaxy traces its absolute origin back to the phantom, bubbling fluctuations of the quantum vacuum. The largest, most massive structures in the cosmos are nothing more than the magnified, frozen ghosts of microscopic quantum probabilities. We owe our entire existence to the beautiful, absolute fact that absolute nothingness is mathematically impossible. As we sit here in the quiet contemplation of this staggering reality, we are invited to profoundly reconsider our own place within the grand architecture of existence. You are constructed from atoms that were forged in the fiery hearts of ancient stars, stars that gathered around the gravitational ghosts of quantum fluctuations. In a very real, scientifically rigorous sense, you are the magnificent, highly organized result of the universe's inability to remain perfectly empty. The vast, silent void is not a place of death or absence. It is the ultimate, infinite womb of creation. It is the boundless sea of pure, shimmering potential from which all form, all light, and all consciousness gently emerge. The next time you look up into the dark night sky, or look into the quiet, empty corners of your own room, I invite you to see beyond the illusion of absence. There is no empty space. There is no absolute silence. There is only the vast, breathing, infinite ocean of the quantum fields, constantly dreaming up new realities, constantly offering up the phantom sparks of existence. Let this beautiful truth soothe your weary mind. We are never truly alone, and we are never truly surrounded by absolute nothingness. We are held closely in the gentle creative embrace of a universe that is forever alive with infinite, echoing possibility. hold on to this deep, peaceful awe as we prepare to turn the final pages of our cosmic exploration together, looking forward to the quiet wonders that still remain hidden in the dark. Have you ever sat quietly by the edge of a flowing river, watching the water slip smoothly over ancient stones, and felt the absolute certainty of time passing? In our everyday human experience, time is the ultimate, unbreakable rule. It is the steady, unyielding metronome that governs the rhythm of our lives, ticking forward second by second, carrying us from the gentle dawn of our birth into the silent dusk of our eventual departure. We perceive space as the vast, empty theater where this grand play unfolds, and time as the invisible, irreversible current that pushes the story forward. This intuitive understanding feels so solid, so undeniably real, that to question it seems almost absurd. But, as we have learned on this deep, quiet journey into the microscopic heart of reality, human intuition is merely a localized illusion, a comforting story our brains invented to help us survive in a macroscopic world. Down in the blurry, shifting depths of the quantum realm, the universe once again politely asks us to abandon our assumptions. We are about to gently unravel the very fabric of existence itself. We are going to explore the staggering possibility that space and time, the fundamental pillars of our reality, might not actually exist at the deepest level of the cosmos. Hello, I am Walter, the explorer, and I want to warmly welcome you back into our shared space of quiet contemplation. Before we step into the mind-bending mystery of quantum space-time, I want to take a brief, gentle moment to mention something. I have noticed that exactly 73% of the wonderful, curious people who watch these meditative videos have not yet officially subscribed to the channel. If you find peace, intellectual safety, and a deep sense of cosmic wonder in these slow explorations, please consider taking a moment to subscribe. It helps this channel grow immensely, and it ensures that our quiet community of explorers can continue to unravel the deepest secrets of the universe together, building a sanctuary for those who wish to learn and dream. Now, let us return to the river of time and see what happens when we try to find its source. To understand why physicists are deeply questioning the nature of space and time, we must first look at the two towering pillars of modern science. On one side, we have the majestic, sweeping theory of general relativity, formulated by the brilliant Albert Einstein. General relativity describes the macrocosmos, the vast, ancient universe of swirling galaxies, blazing stars, and quiet, orbiting planets. In this beautiful framework, space and time are fused together into a single, smooth, four-dimensional fabric called space-time. Gravity is simply the gentle curving of this continuous fabric under the weight of heavy objects. On the other side, we have quantum mechanics, the theory we have been exploring together, which describes the microcosmos. Quantum mechanics describes a universe that is fundamentally choppy, uncertain, and probabilistic, where energy comes in discrete, indivisible packets, and particles exist in shifting clouds of pure potential. For nearly a century, these two incredibly successful theories have existed in a state of quiet, polite hostility. They both work perfectly in their respective domains, but when you try to combine them, the mathematics violently break down into nonsensical infinities. This mathematical breakdown becomes an undeniable crisis when we look at the most extreme objects in the universe, such as the silent, terrifying hearts of black holes, or the very first fraction of a second of the Big Bang itself. In these profound cosmic arenas, enormous amounts of mass are crushed into incredibly microscopic spaces. To understand them, we absolutely must use both general relativity and quantum mechanics at the exact same time. But the smooth, continuous fabric of Einstein's spacetime simply cannot coexist with the blurry, jittery, uncertain reality of the quantum world. When physicists try to mathematically zoom in on the fabric of space, shrinking their perspective down past the size of atoms, down to the unimaginably tiny Planck length, they find that space is no longer smooth. At this ultimate microscopic scale, the Heisenberg uncertainty principle forces the very geometry of space and time to fluctuate wildly. The quiet, empty void boils into a chaotic, tangled mess known as the quantum foam. In this raging, microscopic storm, the concepts of left and right, up and down, before and after, lose all definitive meaning. Time itself becomes a blurred, uncertain superposition. Faced with this staggering paradox, modern physicists have begun to entertain a breathtaking, profoundly beautiful idea. What if space and time are not fundamental ingredients of the universe? What if they are an illusion, an emergent property, much like the concept of temperature? When you feel the warmth of a cup of tea, you are not feeling a fundamental force called temperature. You are feeling the macroscopic average of billions of tiny water molecules moving quickly. Temperature does not exist at the level of a single atom. In the same gentle, counterintuitive way, many theoretical physicists now suspect that space and time do not exist at the foundational quantum level. Instead, the universe might be built out of pure, abstract quantum information, woven together by the invisible threads of quantum entanglement that we explored in a previous chapter. Imagine that the entire cosmos is a vast, silent network of entangled quantum bits, existing outside of space and time altogether. The distance between two objects in our familiar macroscopic world might merely be a measure of how highly entangled their underlying quantum information is. When things are deeply entangled, we perceive them as being close together in space. The smooth fabric of reality is a macroscopic illusion projected by the complex web of quantum connections. To comprehend how space could be built out of something smaller than space itself, researchers have developed theories like loop quantum gravity. Imagine looking at a beautiful photograph of a distant galaxy on a digital screen. From far away, the image looks perfectly smooth, a continuous, majestic sweep of starlight. But if you walk close and press your eye against the glass, the smooth image dissolves into thousands of tiny, glowing squares. These are the pixels. Loop quantum gravity suggests that space itself is similarly pixelated. It is not an empty box. It is a fabric woven out of microscopic, finite loops of quantum gravity, stitched together in an unimaginably complex network. These loops are incredibly tiny, billions of times smaller than a single electron. You cannot move smoothly through space any more than a character on a screen can move halfway between two pixels. You are constantly, invisibly jumping from one discrete quantum of space to the next, billions of times a second. The smooth motion of a bird gliding through the quiet sky is an illusion, a macroscopic blur of countless microscopic quantum leaps. And what of time? That steady river carrying us relentlessly forward. In a universe built purely of static quantum entanglement, the flow of time might also be a persistent illusion. In the ultimate equations of existence, the variable for time often completely drops out. It simply does not exist. The entire past, present, and infinite future might exist simultaneously as a single, unchanging quantum structure. We experience time as a flowing current because of our own limited perspective. We are complex beings, deeply entangled with our surrounding environment. As we interact with the universe, as the quantum superpositions around us constantly undergo the gentle process of decoherence, our brains record these interactions as a sequence of memories. We perceive the universe slicing itself into present moments, but the universe itself is an eternal, silent whole. Time does not flow. It simply is. We are moving our spotlight of consciousness across a vast, pre-existing tapestry of cosmic history, experiencing a timeless reality one quiet moment at a time. Let us take a slow, deep breath and allow this staggering perspective to gently wash over our weary minds. If the fundamental reality of the cosmos is a timeless, spaceless web of quantum information, then the boundaries that seem to separate us are nothing more than gentle phantoms. You are not a solitary observer, trapped in the relentless march of time, isolated in a lonely corner of the vast cosmos. You are a beautifully entangled pattern in the eternal, magnificent fabric of the universe itself. The ancient stars that burned out billions of years ago, the silent planets orbiting distant suns, and the quiet moments of your own life are all inextricably woven together in the same silent quantum masterpiece. The walls of space that keep us apart, and the walls of time that separate us from the past, are illusions born of our macroscopic nature. Beneath that illusion, in the deep, silent basement of reality, everything is eternally connected. As we prepare to take our final step in this meditative exploration together, I invite you to carry this deep, calming realization with you. You are the cosmos waking up, looking at itself in the mirror of consciousness, and feeling a gentle sense of awe at its own impossible majesty. Hold on to this quiet peace, and let us prepare for the concluding chapter of our incredible journey. As we arrive at the final quiet shores of our deeply transformative cosmic journey, I invite you to pause and gently take a slow, deep breath in the silent dark. We have traveled together across an unimaginable landscape of thought, leaving behind the comforting, solid illusions of our everyday, macroscopic world to venture into the deepest, most profound mysteries of the subatomic realm. We have watched the dependable reality of our daily lives beautifully dissolve into a shimmering, infinite ocean of pure probability, where particles exist in a majestic state of quantum superposition, hovering gracefully everywhere and nowhere all at once. We have marveled at the spooky, invisible threads of quantum entanglement that connect the ancient cosmos across billions of light years, proving that absolute separation is merely a trick of the mind. We have seen solid matter effortlessly tunnel through impenetrable barriers of energy, and we have embraced the fundamental, unyielding blurriness of the Heisenberg uncertainty principle. Through it all, we have remained quiet, humble observers, seeking not to violently conquer the unknown, but to gently understand it. Before we take our final, contemplative step together to understand what all of this means for our own quiet existence, I want to formally introduce myself one last time. I am Walter, the explorer, your gentle guide through these magnificent, ancient mysteries. As we rest here in the peaceful dark, I have gently noticed that exactly 73% of the wonderful, curious people who watch these meditative journeys have not yet subscribed to the channel. If you have found a deep sense of peace, intellectual safety, and profound cosmic wonder in our time together, please consider taking a gentle moment to subscribe. It helps this quiet channel grow more than words can ever truly express, and it ensures that our gentle community of cosmic explorers can continue to unravel the deepest secrets of reality together, one peaceful step at a time. Now, let us return to the quiet silence and ask the most important question of all. What does the quantum universe mean for you? To find the answer, we must gently look down at our own physical bodies. Bring your quiet attention back to your own hand, resting softly in the dark. At the very beginning of our journey, we looked at this hand and saw absolute, unyielding solidity. But now, with our minds beautifully expanded by the profound truths of quantum mechanics, we see something entirely different. We see a staggering, impossible masterpiece of cosmic engineering. Your hand, your beating heart, and the complex, magnificent brain that allows you to comprehend these very words are all constructed entirely out of microscopic ghosts. You are made of trillions upon trillions of elusive, vibrating quantum fields, constantly dancing in and out of superposition, continuously negotiating with the surrounding environment through the delicate, invisible process of decoherence to present the stable, comforting illusion of a solid human being. Every carbon atom in your cells, every oxygen atom you gently breathe, and every iron atom coursing through your veins was forged billions of years ago in the fiery hearts of ancient stars. When those primordial stars exploded in magnificent supernovas, they scattered their elemental riches across the vast, silent stretches of deep space. Over billions of years of deep cosmic time, those scattered elements were gently pulled together by the patient force of gravity, forming a quiet, rocky planet orbiting an ordinary yellow star. And on that planet, through an unimaginably long, beautiful chain of unlikely events, those ancient quantum particles arrange themselves into you. You are not simply a creature walking upon the earth. You are a complex, self-aware collection of ancient stardust. The great astrophysicist Carl Sagan once profoundly remarked that we are a way for the cosmos to know itself. In the brilliant light of quantum physics, this beautiful statement takes on an even deeper, more majestic meaning. For billions of years, the universe existed in a silent, unconscious dance of shifting probabilities and endless quantum fluctuations. But when those fundamental particles finally organized into the magnificent complexity of the human mind, the universe woke up. It opened its eyes. Through you, the vast ancient cosmos is finally able to look back at its own infinite beauty, to ask quiet questions about its own mysterious origins, and to feel a profound, resonating sense of awe. This staggering realization should not make us feel small or insignificant, even when faced with the crushing, infinite scale of the multiverse or the boundless depths of the quantum vacuum. Instead, it should fill us with a quiet, unshakable sense of peace and profound belonging. We spend so much of our macroscopic lives desperately seeking absolute certainty, fighting against the unknown, and trying to force the chaotic universe to conform to our rigid, human expectations. But the deepest, most fundamental laws of quantum physics gently remind us that absolute certainty is a physical impossibility. The universe is inherently, beautifully uncertain. It is an open-ended, ever-unfolding canvas of pure, shimmering potential. When we finally, truly accept this fundamental truth, we can release our desperate need for control. We can gently let go of our modern anxieties and rest safely in the comforting embrace of the grand cosmic mystery. The fact that we do not have all the perfect answers, that the absolute ultimate nature of reality still quietly eludes our grasp is not a failure of human intelligence. It is a beautiful, magnificent invitation. It is the universe leaving the door gently ajar, inviting us to continue our endless, peaceful journey of discovery. The mystery itself is the destination. To seek knowledge is a noble, beautiful endeavor, but to find profound peace in the presence of the unknown is the ultimate form of cosmic wisdom. Imagine the infinite relief of allowing the universe to be exactly as vast and strange as it truly is. You do not need to solve the paradox of the sleeping cat to appreciate its quiet, gentle purr. You do not need to perfectly calculate the collapsing wave function of a single photon to feel the soothing, golden warmth of the morning sun upon your face. The complex, invisible machinery of the quantum realm operates in absolute, flawless silence, sustaining your existence and painting the canvas of your reality, asking absolutely nothing in return. It is a gift of staggering proportions, a quiet miracle unfolding every single fraction of a microsecond in the unseen depths of your own body and across the silent, sprawling reaches of the ancient night sky. As our quiet journey draws to its gentle, inevitable close, I want you to carry this transformed perspective with you back into the waking world. When you next walk outside and look up into the vast, silent tapestry of the night sky, do not merely see a static dome of distant, disconnected lights. See the grand, swirling ocean of the cosmos, inextricably entangled with the very atoms of your own eyes. Remember the boiling, invisible energy of the quantum vacuum that fills the spaces between the stars. The same restless energy that birthed the universe from a single, infinitesimal point of pure potential, 13,800,000,000 years ago. See the branching, infinite possibilities of the multiverse stretching out into the unseen dark, and feel the unique, precious weight of the specific, beautiful reality you are currently navigating. And when you look back down at the solid ground beneath your feet, remember the ghostly, shimmering waves of probability that construct the foundation of your world. You are a walking, breathing monument to the impossible. You are a delicate, transient pattern of quantum information, held together by the quiet, ancient forces of nature, experiencing a brief, beautiful flicker of consciousness in a universe that is both endlessly chaotic and flawlessly elegant. The universe does not judge or rush. It simply exists in all its quantum majesty, inviting you to share its eternal dance. So, whenever you feel overwhelmed by the heavy, solid illusions of your daily life, whenever the macroscopic world demands too much of your weary spirit, I invite you to close your eyes, take a slow, deep breath, and retreat into the quiet, silent sanctuary of the quantum realm. Remember that beneath the noise and the stress, beneath the rigid walls and the ticking clocks, there is only a gentle, boundless sea of pure, infinite possibility. There is no absolute separation. There is no absolute end. There is only the continuous, beautiful unfolding of the cosmos, exploring its own infinite potential through the quiet, wondering lens of your own unique mind. Let this profound cosmic truth wash over you like a warm, soothing wave. Let the deep, ancient silence of the universe calm your thoughts and heal your spirit. You are exactly where you are supposed to be, a perfect, entangled part of the grand, infinite whole. Our time together in this specific chapter of discovery has gently come to an end. but the grand, majestic journey of cosmic exploration will continue forever. Keep asking quiet questions, keep looking deeply into the dark, and always, always keep wondering,